Hey guys, Mr. is here to help you guys out with the section 4.3 of chapter 4. So now what we're got is we're going to do operations with polynomials. We'll break it up into two parts. We'll do the easier ones today. So just a little warm up here is to see if we can figure these out. So go ahead, pause. Obviously there are squares here because we want to figure out what goes in there. Let's see if you guys can simplify these expressions. All right, let's see if you're ready to check. So if we are going to cube this expression, we need to cube the 3, cube that, and cube that. So this would be 3 to the third power. All right, x cubed cubed would become x to the ninth. And 2 cubed, or y squared cubed would become to the sixth. All right, 3 cubed is something we can actually figure out. 3 times 3 times 3 is 27. And then x to the ninth, y to the sixth. Notice here, when we take a power to a power, you multiply the exponents. All right, here, if we're combining like terms, we are going to combine the 5 and the negative 7. And then we will combine the 6x and the negative 2x. So that means we would have a negative 2 plus 4x. And here, if we are going to multiply, we got to do x times x is x squared. X times 4 is 4x. We're going to do 3 times x, and then do 3 times 4 is 12. We can combine the like terms, and we will get a x squared plus 7x plus 12. We do all right here. Let's see. Clear all my drawings. That's right. Oh, I guess what I probably could have wrote here, 3 times 3 and 2 times 3. All right, so our goal in this is to make sure we can add and subtract polynomials and to multiply polynomials. Notice here we don't have divide because that's what we're going to do in section 4.4. All right, so a polynomial is a monomial or the sum of two or more monomials. So a monomial is a simple term. It's like an x or a y or x's and y's together, but there's no plus or minus. Once we add or subtract between, that's how it becomes a polynomial. A binomial is the sum of two monomials, and a trinomial is the sum of three. So if you have three terms together, that's a trinomial. Beyond that, there's more terms, there's more names, but after that, we just say how many terms there are. The degree of the polynomial is the greatest degree of any of those terms in the polynomials. Polynomials can be added or subtracted by performing operations indicated like combining terms. You can subtract polynomials by adding the inverse, which is what we talked about before. The sum or difference of polynomials will have the same variables and exponents as the original polynomials. So if I add 5x and 2x together, I don't change the x at all. We could have, though, different coefficients. So the number in front does change. Thus, the sum of the or difference of two polynomials is also a polynomial. A set is closed if and only if an operation on any two elements of the set procedures produces another element of the same set. Because adding or subtracting polynomials results in a polynomial itself, the set of polynomials is closed under the operations of addition and subtraction. All right, so think about it here. If we were going to look at these terms, we got two trinomials. We want to combine like terms. The like terms we would have are just the x squareds and the digits. All right, the x to the fifth is different than the x cubed, even though they're both trinomials, they're at different degrees. All right, so what we're going to do here is determine whether each polynomial or each expression is a polynomial, and if the polynomial, state the degree. All right. So the first one here, this is not a polynomial because here you go. Hey,
You know, Mr. Smith is here.
he is, but I think here, hold on a second. I can tell you what room he's in. He's probably over in like the metal shop.
That would make sense.
Yeah.
Okay.
Yep, I would check over there. I don't actually see a number up next to his name, but I would check
Okay.
over him
Okay,
because I know
Mr.
Mr. Moses in here.
Yeah.
All right, this one is not a polynomial because we have this cube root. Okay, this one is a polynomial here, and because we have separate terms. Now, the degree of the first one is a degree 5 because we have 4 and 1 together that makes 5. This one is degree 9, so that's 2 and 7. So the whole polynomial is degree 9. And then lastly here, this is not expression because even though it is to an x to a power, the negative degree, it does not work. Technically, the negative degree makes it in the denominator, which just doesn't work out. All right, so try that again with these problems here. State the degree of each one of these polynomials. All right, let's see if you got it right. All right, so here we go. This is degree 7. We look at that term. The highest degree is degree 7. This one here, 72 is 9. That's bigger than all. That's 10. And this would be 0 because it is x to the 0 power, or whatever variable to the 0 power. There's none of them. All right, if we want to add polynomials together, we pretty much add like terms. We've talked about this before. All right, so we're going to combine the terms. We can group them together, the cubes together, the squares together, the x's together, and the single digits. We add the numbers in front. We don't change the exponents at all. We can add them vertically if that makes more sense to you. I think it's kind of easier just to group them in our head. Okay. So if we think about it, notice that in some terms that the variables and the exponents are always, let's see, when we're looking at sums of variables, the same variables, the exponents of the term is the original expressions, x cubes, x squared, x's, and the constants. Will this always be the case? Not all the time. Not all of them will have an x squared. Not all the time it will have an x, but maybe one will, one won't, and we'll always have to kind of look out for that. Another way to think of it too is if we don't have one, technically we would have a 0x, which we could write. We just don't need to see. All right, let's check our work here. Let's see if you guys did this one correctly. So pause the video, try to combine these two like terms. All right, adding the x cubes together, we got 6 of them. Adding the x squares together, that would be 2 of them. Adding the x's together, that would be 11. And then we have this -3 by itself. Now, subtracting the polynomials is the same thing. Now, you might want to think of distributing the negative and adding the inverse, or just be careful with your negative signs. So here, it might be easier to distribute the negative and make this a -5x, make that a -9, make that a +3x, and make that a -4. So adding the negative. All right, combining like terms or grouping, and then just adding the numbers in front. We can add them vertically or subtract them vertically if that makes it easier for you. Either way is fine. Now, it's probably good to put placeholders if you're doing vertically, just like how we did before, just to make sure we don't skip any steps. All right, why don't you guys pause this video and try this one on your own. All right, now if we had to group these together, this would be our x cubed. That's the highest power here. We would distribute the negative. So we would start out minus x cubed, 5x cubed. We got 8 minus 2, be 6. -3 minus -6, so that'd be -3 plus 6, which is a +3. And 1 minus -9, which would be 10. Easy peasy. All right, multiplying is probably where we need to do a little math. So polynomials can be multiplied by using the distributive property to multiply each term in one polynomial by each term in the other. So we got to take each part and distribute it to every part. All right, so when polynomials are multiplied, the product is another polynomial. Therefore, the set of polynomials is closed under multiplication. All right, this is similar system of integers. We can also use under closed under multiplication. So if we want to multiply two binomials, we can use a method called FOIL, which means first, outer, inner, last. All right, the first is the first two, so at 2x and x squared. There's the outers, which are the 2x and the -3. Then we do the inners, 4 and x, and then we do the last, 4 and -3. Technically, you don't need to do in that order as long as you do every combination. All right, so here we got to distribute this monomial to those terms. And we just multiply here. Now, you multiply the number in front and then add the exponents together. So 2 times 4 is 8, x to the first, x cubed means x to the fourth. X to the first, x squared, x cubed. So you can see the degrees go up. And we're just multiplying the numbers in front. All right. Now, if we have multiple binomials, we're going to show you what we do. What we're going to do first is to take the first two and FOIL them together. So if I go back to this problem here, let's see if I can scroll back. I got 3a plus 5 and an a minus 7. I'm going to multiply those together by FOILing. So 3a times a is 3a squared. 3a times -7 is -20. 1a. 5 times a is 5a. 5 times -7 is -35. I can combine those like terms in the middle, and we get this as 3a squared minus 6. So that's what the first two together were multiplied. We're then going to take that answer and multiply it by the last set, which if you remember is the 4a plus 1. So we got to distribute. We're going to distribute the 3a to the 4a and the 3a to the 1. We'll distribute the -16a to the 4a and the -16a to the 1, and then even the -35 to the 4a. So remember, we have to distribute each part to the parts on the other side. We end up getting multiple terms here that we will just look to combine. Okay, that's the only a cubed. We have an a squared here and an a squared there. We'll combine those together. We have an a and another a that will combine together, and the 35 on your own. All right, so why don't you pause this video? Why don't you guys give this next one a try? Try to multiply these two together, or these three together. All right, so the first thing we're going to do, we're going to distribute the 2r to these first two terms. We're going to leave this r plus 4 alone. All right, so let's see. This would be -2 times 5 is -10, r and r squared. -2 times 1 is +2, and we have an r. Next, -3 times 5 is -15, and then we have an r. And then -3 times -1 is a +3, leaving the r plus 4 alone. Just going to combine like terms here. So we can combine those together. We get -10r squared minus 13r plus 3. All right, now we need to distribute this. So we're going to multiply the -10r squared to the r and the 4. So we get -10r cubed plus, actually not plus, but minus 40r squared. Then distribute the -13. So -13r times r is -13r squared. And then -13 times +4 is a negative, what is that? 401252 r. One more set. We're going to multiply the 3 times the r and the 4. So we get 3r plus 12. We're going to combine like terms. We don't have any r cubes other than the -10. We got -40 and -13. That's a -53 r squared. We got a -52 and a +3, so that's going to be a -49 r, and then we got a 12 by itself. Let's check. Did we do that right? I think that's the same answer. Yay. Okay, we can use this in story problems as well. You guys can see here with the story problems, if we wanted to go ahead and find the volume of the cake, what we can do, we can just find the volume of the first one here by multiplying these terms together. Now, this is kind of crazy. We're not going to do this one. This isn't relevant. Let's be honest here. Who's making a cake with variables like such? Now, I understand the terms here, but what we want to do is just, if we would multiply. So now when we multiply, it technically doesn't matter if we multiply these two together and then multiply it by that, or if we multiply these two together and multiply that answer by x, or vice versa. But we can go through there. All right, here's the exit ticket. See if you guys can get those same answers here. Remember, when we're adding, you're just combining like terms. Subtracting, you're adding the negative. And then when we're multiplying, we are distributing. Thank you guys for watching. You guys have a great rest of your day, and good luck on your CYU.